fast. 1 out of, it's going to be ultimately 1 out of 8. How do you reason your way through it? This is, I mean, you can reason your way any way you want, as long as you reason like enough to get to the right answer. The only way that this child will be a colorblind is if it's what? It's a male, right? Because females cannot be colorblind if their dad is normal. Because remember, their dad is normal, so their dad is automatically big A1, right? So the only way that this child would be colorblind is if the dad gives him the little y, I mean the big Y, and his mom gives him the little a. Does that make sense? Okay, and for his mom to give him the little a, she has to have it in the first place. But we don't know that for sure. The only way she can have it in the first place is if what? Is if her mom gave it to her. So now it all boils down to here. What's the probability that the little a will come down? It's 1/2. Please stop me if it's not making sense. Because you know for a fact, her dad gave her the big A. That's what makes her normal, right? So she, in essence, is XA wild. Her dad gave her the big A. Her mom could have easily given her one or the other. So you can't tell. You know that it's 50-50. So the probability that the mom is a carrier is 1/2. If she is a carrier, the probability that she'll give it to her child is what? Is also 1/2. If she is assumed to be a carrier, she still has an equal chance of getting either the big or the little. It's another half. What's the final half? That the father will give the Y. So it's half times half times half. Let's do it a little bit differently to hopefully strengthen this. If I told you they have a son, their firstborn is indeed a son, what's the likelihood that he's colorblind? Now it's 1/4. Why? Because you already know he's a son. Now it boils down to the last two halves. The probability that his mom is a carrier is 1/2, and the probability that she'll give him the little a is also 1/2. Half times half. That's as convoluted. But remember, there's all a... so any questions about this?
So if you say that if you ask the probability of the first child being colorblind, you take the sex into account, the 1/2. But if you already establish that it's a boy or girl,
Of course.
you don't, you throw that
If it's a
out.
girl, it's 0. She's not going to be colorblind.
Okay.
Any questions about this type of... Now let's work out a few probabilities. What's the probability that you have 4 children and they're all of the same sex? A family has 4 children, you don't know them. What's the likelihood that they'll be all of the same sex? 1 out of 16. Not 16. No, not 1 out of 16. 1 out of 8. Why? Because they could be all boys, 1/2, 4 times. They could be all girls, and now you do what? It's either or, you add them up, right? So remember, when there's a choice, you have to use the either or. Either all boys, half times half, 4 times 1/16. All girls, half times half, and then it's either or, you have to add them up. Okay. So you can introduce a disease, let's say we're dealing with albinism. Albinism is autosomal recessive. And for the first part, other than chapter 7, as I mentioned in class, if there is a disease, I'll tell you what it is. It's autosomal dominant, X-linked dominant, or so on. But I'll tell you, albinism is an autosomal recessive disorder. You have a couple of, both of whom are carriers, want to plan or are starting a family. And for whatever reason, they want to find out the probability that at least 2 of their children, or let's put it this way, at least, at least one of their children, they want 4 children, they want to know what's the probability that at least one of their children will be albino. What's that probability? They have 4 children, they want the probability that at least one will be albino. Now, remember, there's 2 ways to do this. There's a long way, there's a short way. Now, clearly you want the short way here. What is the short way? Exactly. The only way that does not solve your problem is the one you're looking for, right? At least 1 out of 4 is albino, is covered by all possibilities except which one? All 4 are what? Normal. You calculate all 4 normal, 3/4 times 3/4 times 3/4 times 3/4, and then you do what? You subtract it from 1. Now, sometimes the shorter one will not work, or at least it will be almost as equal as the long one. Let me give you the other scenario. Now you have 4 children, you want at least 2 to be normal, or at least 2 to be albino, whatever the case is, at least 2 albinos. So 4 children, at least 2 albinos. So what do you do? At least 2 albinos is what? It's 2 albinos, 2 normal, 3 albinos, 1 normal, 4 albinos, 0 normal. These are all your choices. So what do? You calculate each one of them. Let's call this X, Y, Z. And then you do what? What do you do with X, Y, and Z? You add them up, right? Z is the easiest way to figure out. It's 3/4 times 3/4 all to the power 4. So this one is easy. This one is 3/4 all to the 4. How do you calculate these two? There are many ways to do them. The most straightforward one is the binomial theorem. So here you'd have to remember the binomial theorem. For x, what would x be? The probability is what? It's going to be 4 factorial, right? Because that's how many children you want total. You want 2 of them to be abnormal, 2 of them to be normal. The probability of abnormal is what? 1/4 to the power 2. The probability of normal is 3/4 to the power 2. That is your x. Y, yeah, y is the same thing. Let me finish y and I'll... what would y be here? It would be 4 factorial over what? 3 factorial, 1 factorial, and you change the powers. Yes?
With the z, is that supposed to be 3/4 or should it be 1/4? Are you calculating the normal or are you calculating...
Okay, my bad, thank you. It should be, this is albino, so it should be 1/4.
Okay.
Thank you. Because you want albino. Okay, so it's 1/4. Right? Here it would be what? 4 factorial would still hold, 3 factorial, 1 factorial, 1/4 to the power 3, 3/4 to the power 1. That's the at least type. It's just a matter of, again, calculating it and then adding them up. Any questions about probability?